Hello Steens, this is a review of the notes that we took in class today regarding scatter plots and finding correlation coefficients. So we reviewed quickly about positive and negative trends. We talked about finding the line of best fit by trying to find a line that goes through the middle of the data so that you have pretty much the same number on top of as you do on bottom of points above the line and below the line. Then you can use some of the points from your data, and you can use our other notes that we took. Well, not that we took, but our steps to perform linear regression to help us with that. So we can take the points that we saw from the line that we drew, get some points that are on it or close to it, put those into stat, and then do the linear regression. And to get our equation, y equals 6.61x plus 7.24, just rounded to the nearest hundredth on this. To get the correlation coefficient for this data, you had to turn on diagnostics. So we went through and went to mode, stat diagnostics, turned that on, hit enter, and then re-performed the linear regression so that we could see the R value. So here is the R value. So that came up to 0.99998. So that's a very good correlation because this is very close to 1. We decided to look at an estimate of what would 35 be, and we used the line of best fit, the equation there, to get 239. And then we said, well, what about if there's 60 people? Then that would come out to about 404. On the second example, we can see that this is a negative correlation. Again, we tried to find the same number of points above the line as we would have below, using point values of points in the scatter plot that are close to or on the line of best fit that we've drawn. Put that again into stat, perform the linear regression, and since we had already turned on the diagnostics, it went ahead and gave us the R value of 0.999. And because this is negative, sorry, this should have been a negative 0.999, forgot to write that down. Here we have our line of best fit. We see that it's negative, so our slope is negative. Our correlation coefficient is also negative. So if you have a negative correlation, you're looking for your coefficient to be as close to -1 as possible. The closer it is to -1, the more accurate your predictions will be. So here we found that if we predicted, or if we looked at $60, we found that that gave us a negative number. So that meant the number of t-shirts went to 0 somewhere around just before you got to 60. For no correlation, you do not have an equation, and your correlation coefficient would be 0. So there's no estimating or predicting there. For a table of values, again, you're just going to go to the calculator in stat, enter your data into L1 and L2, perform the linear regression. On this one, we used exactly what A and B were. We used our R value here. We estimated that the year 2000, you would have 343 cases, and we predicted that in 2004, somewhere around 2003, 2004, the number of cases would go to 0. For the height here, we ended up with 62x plus 105. Again, we simply used the calculator, put our values into stat, performed the linear regression, and that gave us this information. Our correlation coefficient is 0.99, very close to 1, so this will give us good predictive values. We said, what if it was 20 years later? How tall would this thing be? It would be 13.45 feet. And at 6 years, it would be 4.77 feet. And then finally, again, we had no trend. Sorry, this should have been 0. I don't know why I put that there. This should have been the NA. And here was the 0. So if you have no correlation, your correlation coefficient is 0. If you have a negative correlation, then your correlation coefficient needs to be as close to -1 as you can get it. And if it's a positive correlation, then you need your correlation coefficient to be as close to +1 as you can. So this was information that we did in class on scatter plots and correlation coefficients.